Many times in your study of functions, you're going to want to find the inverse of a function. So you want to be a little bit careful just in the terminology. The inverse of a function is not its reciprocal, and it's not its opposite in terms of negative either. It's a completely different concept. What you need to do for an inverse function is, let's say we have a function y equals f of x. That means whenever you plug an x into this function, whatever the function does, you get an output, the y. The inverse function takes those y's as inputs and then gives you back the x's. So, another way you could write this is that, and that's the notation for a function inverse, it's f with a -1 power. So, this is saying the same thing as this. This is saying if I use the inverse function and plug in y's, I will get x's in return. So that is the inverse function. Let's think about what those mean both algebraically and graphically. One way you can always figure out if something is its inverse is you can switch x and y and then resolve the equation. So for example, if you had something like this, a simple line, y equals 2x plus 3, and you wanted to find its inverse, what you would do is you would switch x and y, and now solve this for y. So you would need to subtract 3 and divide by 2. So this right here is the inverse of what we started with. Now, one way you can always check if two functions are inverse is if you have them without doing all that, because sometimes your functions are going to be a little bit more complex than this. You can use this property, a function composed with its inverse, or the inverse composed with a function, always has to just equal the value x, no matter what. So if you have if you have a function and its inverse, you can compose them in either order, and if they are in fact inverses, you'll always get x. So that's another way to test. And finally, you can test by a graphical approach. So an inverse function is one that is a reflection across the line y equals x. So remember, y equals x is your most basic line. It has a slope of 1 and goes right through the origin. So if you have any function, let's just say we have another line, and it looks like that, its inverse will be its reflection along this dotted line. So wherever it crosses the dotted line, it'll still be there, and then it needs to be the exact mirror image, which in this case would probably look something like that. If you tilt your head, you can see that's a mirror image there. So if this is f, this is f inverse. Now, let me get to something a little bit tricky about inverses, and that some functions do not have inverses. So, let's look at a really basic function that doesn't have an inverse. F of x equals x squared. Looks like our parabola. Let's see why this doesn't have an inverse. Well, if we reflect this across the line y equals x, we're going to get basically looking like a sideways parabola if you reflect it across the line y equals x. Here's the problem though, that result that we just got, this sideways parabola, is not a function because it doesn't pass the vertical line test. So this function x squared actually does not have an inverse. However, if we were to just cut off the left side of that parabola, on our inverse that would cut off this bottom part, and now it would have an inverse, and it's just the top of that. So if you restrict your domain for a function that doesn't normally have an inverse, you can get an inverse. So if you had f of x equals x squared for only x greater than or equal to 0, meaning only the right part of your parabola, then this does have an inverse. A function that does not have an inverse like this is what we know as is not 1-to-1. So a function must be 1-to-1 in order to have an inverse, and the graphical way of looking at it is a function is 1-to-1 if it passes the horizontal line test. So in our normal x squared graph, it does not pass the horizontal line test. So it's not 1-to-1. It does not have an inverse. However, once we cut this left part off, it does pass the horizontal line test, which means it is 1-to-1, which means it has an inverse. So that's what you need to know about it.